Hey, iqkid here. Today we're going to talk about some more of the gas laws, and today we're doing Charles' law. So to review the different gas laws. So there's Boyle's law, there's Charles' law, which is what we're doing today, Avogadro's law, and the ideal gas law. And these deal with the relationships between the basic gas properties, which are pressure, which we represent with capital P, volume, which we represent with capital V, temperature, which we represent with capital T, and the amount in moles, which we represent with the lowercase n. Okay, and yeah, so all of these properties are interrelated through those gas laws. Okay, so to look at Charles' law, in Charles' law, we have that V is proportional, is V alpha T at constant P and N. So this means if the pressure and the amount in moles, P and N, of a given gas are constant, then the volume of that gas, V, is directly proportional, so proportional to the temperature, T, in Kelvin, of the gas. And we can represent this with the equation V1 over T1 equals V2 over T2. The initial volume divided by the initial temperature is equal to the final volume divided by the final temperature. So V1 would be initial, or the 1 subscript 1 means initial and subscript 2 means final. So we can represent this relationship with V up arrow, T up arrow. So as the volume increases, the temperature increases, and as the volume decreases, the temperature decreases, and vice versa. Okay, so now that we've covered Charles' law, let's look at an example. In this example, we have a sample of CO2 gas with a volume of 35 milliliters at 37 degrees Celsius, and it is cooled to 300.15 Kelvin. What is the new volume? So step 1 is to convert. So we need to convert the Celsius to Kelvin. So plus 273.15 is equal to 310.15 Kelvin. Okay, so then step 2 is to write the formula. So the formula is V1 over T1 equals V2 over T2. Okay, and then step 3 is to plug and chug. So remember V1 over T1 equals V2 over T2. So V1 was 35 milliliters. The initial volume is 35 milliliters. The initial temperature is 310.15 Kelvin. And that's equal to the final volume over the final temperature, which was 300.15 Kelvin. Okay, so then we can set the final volume equal to 35 milliliters times 300.15 Kelvin over 310.15 Kelvin. So we're just isolating the unknown. And then we get that V2 is equal to 151378 milliliters. So then we need to keep in mind the significant figures. So we get for our final answer that V2 is 34 milliliters. And that's your final answer. So now let's do another example. In this example, we have a sample of SO3 gas in a volume of 33 milliliters, and it is heated to a temperature of 30.1 degrees Celsius and a volume of 0.0450 liters. So what is the initial temperature in Kelvin? So step 1 is to convert. So we need to convert our our initial temperature, which was in degrees Celsius, to Kelvin. So 30.1 degrees Celsius plus 273.15 equals 303.25 Kelvin. And then we also need to convert our liters into milliliters, or vice versa. But we're going to do liters into milliliters. So milliliters times 1,000 milliliters. Oops, that's not milliliters. 1,000 liters. Okay, over 1 liter. Okay, and we get from that 45.0 milliliters. Okay, so then step 2 is to write the formula. So V1 over T1 equals V2 over T2. Okay, so then finally let's go on to step 3, which is to plug and chug. So V1 over T1 equals V2 over T2. So V1, the initial volume, is 33.0 milliliters over the initial temperature, which is what we're trying to find, is equal to the final volume, which is 45.0 milliliters. We converted to find that, over 303.25 Kelvin, the final temperature, which we also converted to find. So then let's isolate the unknown. So the initial volume is equal to 303.25 Kelvin times 33.0 milliliters all over 45.0 milliliters. Okay, so then we have the initial temperature is equal to 222.383 repeating Kelvin. So then we need to take into consideration the significant figures. So with that, we get that the initial temperature is equal to 222 Kelvin. That's your final answer. I hope this helped. If you have any questions or like me to make a suggestion for my next video, feel free to contact me through any of the emails in the description or my online website, which I just created recently, which the link will also be in the description. And yeah, so iqkid signing off. Hope this helped.